So, what's the hardest possible projectile problem I could ask you? This will be if the initial and final points are not the same, the initial and final heights. So what we'll do is imagine we're at the top of a 75-meter tall building. We're going to throw a rock at 35 meters per second, and we throw it at an angle of 60 degrees above the horizontal. We want to know all the same questions as in the last problem. What's the range? How long is it in the air? How high does it go? How long does it take to reach max height? What's its velocity and impact? Again, we put down what we know. We know the y initial is 75, y final is 0 since it lands on the ground. We know AY and AX is 0. And we find our initial x and y velocities. 17.5 meters per second in the x direction, 30.3 in the y. Notice it makes sense that y is larger because we're throwing it at an angle greater than 45 degrees to the horizontal. So to find the time in air, we use the exact same formula as before. This is what makes it the hardest possible projectile problem. We have to use the quadratic formula. So you can solve this with the methods we discussed before using the quadratic formula, or you can have your calculator do it if you have one of the fancier ones. Anyway, you get two answers, a negative root and a positive root, and we want the positive root, so we get 8.08 seconds in air. We use that to find the range exactly as before. There is no acceleration in the x direction. We plug in our values for x velocity and time, and we get 141 meters. To answer part 3, we have to decide where our height is measured from. So on a test, I'd have to make sure to specify that I want the height above ground or above the roof of the building, or I'd have to take both answers. So if we want to find the maximum height above ground, we use this. We know that Vy final is going to be 0 when we reach max height. We know Vy initial, we're looking for Yf, and we know Y initial is 0. So we plug all these, Y initial is 75 meters. That's our initial height above the ground. We plug all these in, we get Y final is 121.8 meters. For the time to max height, this is not a symmetric problem, so we can't just divide the total time by 2. We have to use the more reliable method, which is this equation where we say Vyf equals 0 at the peak. When we do this, we plug it in, we solve for t, and we get 3.1 seconds. Velocity at impact, we do that the same way as before. Vx final is equal to Vx initial, and Vy final is this kinematic equation. We put in our initial y velocity, acceleration, and our total time in air. We get negative 48.9 meters per second. Magnitude of our final velocity, square root of the sum of the squares of the components, 51.9 meters per second, and the arctangent is negative 70.3 degrees. As the building gets taller and taller, if there are no other changes, we would eventually expect this theta to approach negative 90 degrees. The only other things I could possibly ask you that I can even think of would be to give you a specific time and ask for x or y positions or velocities. If we do this for, say, t equals 2 seconds, we know x final, it's the same formula as before. We use just velocity times time, we get 35 meters. Y position at 2 seconds, we're using this longest kinematic equation again, and we're just plugging in t equals 2. When we do that, we get 116 meters. Vx final, there's no thinking required. It's always equal to Vx initial. And Vy final, we're using this equation again, and we plug in 2 seconds. This is all there is to know about projectile problems in this class.